Right, today I am going to teach you the concept, the difference of two squares. Right? Okay, look at this example. This is our theory. A squared minus b squared is equal to a minus b, a plus b. Right? If I have a square, a squared, and if I have the difference between two squares, I can always represent it in the form a minus b into, brackets means always into, a plus b. Right. We are going to implement this theory onto these following examples. Right. Now, first of all, I am going to teach you factorizing. Right. Factorizing means you can use this theorem and simplify it, and you can't get an exact answer. But evaluate means you can get an exact answer. Right. Factorize the following. Now, first of all, I have to check whether all these numbers are square numbers. Right, fine. A, I have the power 2, so it's a square number. B is a square number. What about 4? I can form it as a square number, right? I can rewrite this as 2a. 2 to the power 2 is 4. A squared minus b squared. Right, I will rewrite this as whole thing squared. Right? So now it's difference between two squares. A square minus b squared. I can write it as 2a minus b 2a plus b. Right? Now we will move on to the next example. In this example, 3 is not a square number, neither 27 is not an square number. Right? So what am I going to do is I will just take 3 out of this full equation. Take 3 out. If I take 3 out, I am left with x squared and a 9 is left and y squared. Now, you know I can rewrite this as a square number. Right? So, 3x squared 3y whole thing squared is equal to this. See, 3 squared is 9, y squared is y squared. So now I can rewrite this one. 3 x minus 3y x plus 3y. So 3 is out. 3 is common for all this. Right. Moving on to the next one. Here I have to place this also as a square number. You know 1 square is what? Always 1. So x squared, 1 squared, 9 I can write it as 3 squared. So I will just write it as whole thing square. Right. Now I can rewrite my answer as x minus 1 over 3, x plus 1 over 3. Moving on to the next one. Again, 18 is not a square number. 8 is also not a square number. So I will just take a common out of this. I will take 2 out of this. If I take 2 out of 18, I am left with 9. 9 is a square number. If I take 2 out of 8, right? So I am left with 4. 4 is also a square number. So I will just take 2 out. So 2, 9 m square. Taken 2 out. So 4 m n square. Right. Now here can you see I can take, sorry, this is m cube. I can take another m out because m to the power 3 is not a square number. So I will take 2m out. Then I am left with 9m square 4n square. You know 2, 9 I can write it as 3 to the power 2. Right? 4 I can write it as 2 to the power 2. So now I can place this as whole thing square. Place this as whole thing square. So I can rewrite my answer 2m 3m minus 2n 3m plus 2n. Right. Now we will move on to the next part. Evaluate the following. Evaluate means again it's the same theory. I had used the same theory and get my answer. Right. 81 square minus 80 squared. I can write it as 81 minus 80 into 81 plus 80. 81 take away 80 is 1. So 81 plus this is 161, so 1 into 161 is 161. Moving on to the next part. Again same thing. 0.003 minus 0.002 into 0.003 plus 0.002. You know, 0.003 take away 0.002 is 0.001 into 0.005. You know, if I multiply this, 1 into 5 is 5, but power is what? I can rewrite this as 1 to the power 1 into 10 to the power minus 3. This is 5 into 10 to the power minus 3. So I can rewrite it as 1 into 5 is 5, 10 to the power minus 6. Right. I will bring this question down simply because I don't have enough space here. Okay. So for this part, my answer is this. This is my answer. Right. Moving on to this again. Difference between two squares, a square minus b squared. I can write it as a minus b, a plus b. So 7.68 minus 2.32 into 7.68 plus 2.32. Right. 8 take away 2 is 6. 6 take away 3 is 3. 7 take away 2 is 5. Into 8 plus 2 is 10. 6 plus 3 is 9. 9 plus 1, 10. Which is 10. So what's the answer actually? 10. 10 into 5.36. So anything multiplied by 10, you get 53.6 as the answer. Right. I hope this video is helpful for you to study this concept. Next I will be uploading another video on the solutions of completing the squares. Thank you, Sheila.